we've got another rational function up here on the board, and this time we're taking the limit as x goes to negative infinity. Now here, the lead term on top is 5x, that has degree 1. The lead term on bottom is 2x cubed, that has degree 3. 3 is the power we're going to be concerned with. So 3 is the biggest power on bottom. So right now, we're just remembering, because I said so, that we're using the biggest power on bottom. In the next example, I promise I'll explain why we want the biggest power on bottom rather than the biggest power on top. All right, so I'm going to multiply by 1 in the form of 1 over x cubed over 1 over x cubed. And I think what I'm going to do for all of these examples is work out the formal justification and then use the shortcut that I showed you to check things. And that's something that you can definitely do. Even if on an exam I say provide a formal justification, if you want to use the shortcut to make sure that your answer checks and you're getting what you think you should be getting, great idea. All right, so this becomes the limit as x goes to negative infinity of 5x over x cubed plus 4 over x cubed over 2x cubed over x cubed plus 5 over x cubed. So that's the limit as x goes to negative infinity. This is going to become 5 over x squared plus 4 over x cubed over 2 plus 5 over x cubed. So now, every piece that still has x's in the denominators is going off to 0. So we're getting 0 plus 0 over 2 plus 0. We're getting 0 over 2, which is 0. All right, if we were to check this using the shortcut of just looking at the fraction of the lead terms, that would be limit as x goes to negative infinity of 5x over 2x cubed. Canceling an x, that becomes the limit as x goes to negative infinity of 5 over 2x squared. We've got x's on the bottom, and x is getting really, really big. Just happens to be in the negative direction. That's going to go to 0. As a general rule, if the power on bottom is bigger than the power on top, it's going to be 0. Because what's happening is top and bottom are both getting big, but the bottom is getting big way faster than the top is. So comparatively speaking, the bottom is a lot bigger than the top, so you're dividing by something big, you're getting something small. The limit is going to be 0. Now in the next video, we'll take a look at an example where the roles are reversed, where the bigger power is on top rather than on bottom. We can sort of see a little bit of foreshadowing here. When the biggest power was on bottom and we multiplied through by the reciprocal of that power, it made every term on the top go to 0. So that the top simply went to 0. When we evaluated, the top was 0 of our limit. It's okay to have 0 on top of a fraction. I'd rather avoid having 0 on bottom of a fraction, which is why we're using the biggest power on bottom. But we'll take a look at that in some more depth in the next example.